For decades, the universe guarded its planets like secrets in the dark, revealing them only through shadows, wobbles, or fleeting dimmings of distant stars. Every exoplanet discovered felt indirect, inferred, never truly seen. Ground-based telescopes glimpsed a handful of glowing giants, but always blurred by atmosphere or drowned in stellar glare. Space telescopes hinted at more, yet none could pierce the light to capture a world in plain view. But then the James Webb Space Telescope turned its golden gaze outward and did something unprecedented. It didn't just detect a planet, it photographed one. Not a recycled image from years past, not an artist's conception, but a fresh, direct capture of another world. A faint point of infrared light orbiting its star, isolated against the void with clarity that forced astronomers to rewrite what they believed possible. This time, Webb didn't infer existence. It revealed it, pixel by pixel, in a breakthrough so sharp that the odds of direct imaging success on this scale approach a staggering 99.9%. What makes this moment so profound is not only the image itself, but what it demands we accept. For the first time, humanity holds a real photograph of a planet around another sun, taken not by accident or legacy data, but by deliberate observation in the telescope's prime. This is no vague silhouette or statistical shadow. It is light emitted from the planet's own heated surface, traveling across light years to register on Webb's detectors after the star's overwhelming brilliance was meticulously blocked. The convergence of technology, coronagraph precision, infrared sensitivity, mirror alignment, aligned so perfectly that a world once hidden now stands exposed. If Webb can achieve this now, then the era of merely detecting exoplanets is ending. The era of seeing them, studying them as individual worlds, has begun. When Webb focused on the young star TWA-7, few expected history to shift. This sun-like star, barely millions of years old, was known for its striking debris disk, 3 distinct rings carved by unseen forces. Gaps in those rings hinted at sculptors, perhaps planets clearing paths as they formed. But direct proof remained elusive. Webb changed that in an instant. Using its mid-infrared instrument and a finely crafted coronagraph, the telescope subdued the star's light and revealed a faint source nestled in one of those gaps. A Saturn mass world, glowing from residual formation heat, orbiting at a distance where dust and gas still swirl. What lies in that image is where the revelation deepens. This is not a massive hot Jupiter or a distant supergiant easily separated from its star. It is the lightest exoplanet ever directly imaged, a sub-Jovian world, roughly 1/3 Jupiter's mass, yet captured with such contrast that its position, brightness, and even orbital implications emerge clearly. Simulations confirm it. A planet shepherding the disk, creating the observed rings and gaps through gravitational influence. This world checks milestones scientists once thought decades away. Young, forming systems visible in detail, planets of intermediate mass isolated against debris. Webb forces us to confront a transformative truth. Direct imaging is no longer reserved for extremes. It is becoming routine for worlds increasingly like those in our own system. While TWA-7 delivered the first true discovery, another system amplified the breakthrough by refusing simplicity. The iconic HR 8799, long famous for its 4 directly imaged giants, came under Webb's scrutiny and yielded details ground telescopes could only dream of. 4 massive planets, orbiting far from their young star, appeared not as blurry specks, but as distinct points with spectral fingerprints embedded in the light. Webb peeled back atmospheric layers, detecting carbon dioxide and carbon monoxide in abundances that tell a story of formation. Imagine these worlds as youthful Jupiters still radiating birth heat, their gases churning in disequilibrium. The detection of heavy elements, the signatures of core accretion. These are not vague possibilities but measured realities. Webb's images show planets built from solid cores that gathered gas, mirroring how Jupiter and Saturn emerged in our system. Even more compelling are the atmospheric dynamics. Convection bringing deep gases upward, clouds of silicates or metals scattering light. In other words, HR 8799 reveals a planetary family caught in adolescence, dynamically active, chemically rich. The analogy is powerfully direct. If our gas giants formed this way, why would these be exceptions? Webb transforms HR 8799 from a landmark into a template, a system where multiple worlds can be photographed and dissected simultaneously. When Webb turned to Epsilon Indiab, proximity added urgency to the achievement. This cold gas giant, orbiting a star just 12 light-years away, had been glimpsed before, but Webb's coronagraph captured it with unprecedented coolness. Temperatures near freezing, far removed from the scorching youth of prior targets. The image shows a world surprisingly dim, its light absorbed by thick atmospheric layers, rich in methane and possibly clouds. This planet challenges assumptions about brightness and detectability. Older, cooler worlds were thought too faint for direct imaging, yet here one shines through, blocked starlight revealing a Jupiter analog in temperature and separation. Its atmosphere, probed in infrared bands, hints at complex chemistry without extreme heat-driving reactions. Webb elevates Epsilon Indiab from confirmation to benchmark, proof that mature cold giants can be photographed, opening doors to imaging planets more like our own outer worlds. The HR 8799 system may dominate headlines for its multiplicity, but TWA7's single discovery disrupts by its solitude and subtlety. A lone Saturn mass companion in a gapped disk, it embodies formation in progress, gravitational carving visible in real time. Webb's image isolates it cleanly, its infrared glow betraying youth and mass. What sets TWA7b apart is accessibility. Lighter than prior direct targets, closer in scale to solar system planets, it bridges the gap between giants and terrestrials. Models align perfectly, orbital simulations matching observed position, disk interactions explaining ring structures. This is the kind of patience formation requires. Not explosive growth, but steady accumulation. If TWA7b represents a common phase, then young systems may team with such sculptors, quietly shaping debris into future homes. At first glance, cold worlds like Epsilon Indiab seem detached from the fiery youth of HR 8799 or TWA7. One glows dimly from age, the others brightly from birth. Yet Webb's comparisons reveal unity. All emit in infrared, all require coronagraphic mastery to separate from stars. Think of Epsilon Indiab as a settled elder, its atmosphere equilibrated, methane dominant. Contrast that with HR 8799's churning gases, carbon compounds aloft from heat. Then enters TWA7b, mid-formation, its light tied to disk interactions. The comparison is stark. Youth amplifies signal, maturity demands sensitivity, and Webb delivers both with precision that proves versatility. Disks alone do not guarantee planets. How they are shaped reveals everything. TWA7's rings and gaps scream planetary influence, cleared lanes like highways through dust. HR 8799's wider orbits leave broader signatures, multiple worlds interacting over vast distances. Epsilon Indiab, mature, orbits in cleared space, its disk long dissipated. Webb's images suggest something profound. Direct visibility favors systems where planets assert dominance, carving, migrating, stabilizing. Life may prefer quieter maturity, but imaging thrives on dynamism. The safest targets may be the ones still announcing presence through structure. When these captures are viewed individually, each feels groundbreaking. Together they form a progression impossible to dismiss. TWA7 shows discovery of new worlds in formation. HR 8799 proves multi-planet imaging with chemistry. Epsilon Indiab demonstrates cold, mature giants are reachable. This is no longer isolated triumphs. It is a spectrum of direct imaging, from young and hot to old and cold, from massive multiples to intermediate singles, from debris embedded to cleared orbits. Webb reveals that seeing exoplanets does not demand extremes, only advanced suppression of starlight. And when so many different worlds yield to that gaze, the implication is that the universe is filled with photographable planets, not indifferent to revelation. For years, systems like HR 8799, TWA7, and Epsilon Indi were treated as rarities, direct imaging's exclusive domain, giants only, each one celebrated in isolation to preserve the narrative of difficulty. James Webb makes that isolation untenable. When these worlds are aligned, a pattern emerges. They are not outliers but representatives, repeating under varied conditions. TWA7 demonstrates new discovery in disks. HR 8799 shows atmospheric depth across multiples. Epsilon Indi AB proves cooler targets viable. Individually, each advances technique. Together they form an imaging revolution. This is the threshold where exoplanet science crosses into visibility. The focus shifts from inferring presence to portraying character. Webb suggests that once contrast is conquered, nature doesn't hide planets. It displays them across ages, masses, architectures, as if direct imaging itself is a natural progression, not a rare feat. One of the deepest insights from these images is that planets reveal themselves through diversity. Some blaze from youth like HR 8799's quartet. Others embed in disks like TWA 7b. Some endure quietly like Epsilon Indiab. Webb shows that imaging does not rely on one ideal, only sufficient separation and emission. It's like watching planetary systems offer multiple windows: formation, multiplicity, maturity. Webb proves flexibility is key. If hot youth fades, target cooler ages. If singles evade, seek multiples. This is not limitation. This is expansion built into the method itself. When worlds across this range independently become visible, the notion that direct imaging is niche begins to crumble. Instead, it looks like the beginning of a catalogue where planets are seen, not just counted. At some point, successes accumulate into inevitability. One direct image is milestone. Several across types is momentum. A growing collection spanning formation stages pushes past doubt. James Webb doesn't need to image Earth twins yet to transform the field. It only needs to show that planets are visible in abundance, across conditions once deemed impossible. Each capture adds contrast. Each cooler world adds range. Each atmospheric detection adds depth. Each new discovery adds numbers. View them separately and caution persists. View them together and caution yields to anticipation. The capability curve accelerates, not slowly but decisively, until the idea that most planets remain unseen forever becomes harder to sustain than the reality that many will soon be photographed. This is where 99.9% shifts from hope to projection. It is no longer about one image, but about an emerging gallery. Webb is not capturing exceptions. It is unveiling the norm. What makes this era defining is not a single frame or confirmed detail, but an irreversible expansion of vision. Before Webb, humanity inferred distant worlds through indirect traces. After Webb, the honest pursuit becomes portraying them as places, with surfaces, atmospheres, contexts. TWA7, HR 8799, Epsilon Indi AB together mark the transition from inference to observation. This is the pivotal shift, the point where the cosmos stops concealing planets and starts presenting them, even if dimly, even if far. The realization arrives gradually but irrevocably. The barriers to seeing other worlds are technological, not cosmic. They are surmountable, and if surmountable, then planetary visibility is not exceptional. It is expectant. James Webb has not closed the book on exoplanet discovery, but it has opened a new chapter of direct encounter. And once encounter begins, intimacy is only a matter of refinement. For millennia, humanity gazed at stars and wondered what orbited them, imagining worlds in myth and mathematics, but never seeing. The James Webb Space Telescope didn't imagine, it photographed. When you align TWA-7's nascent companion beside HR-8799's familial giants, when you place Epsilon Indiab's cool endurance with the formative chaos of debris disks, when you recognize that Webb's coronagraphs can isolate infrared whispers across ages and architectures, a profound truth emerges. Planets are no longer abstract detections. They are visible entities, something the universe yields when observed with sufficient resolve. This is why the breakthrough feels not like exaggeration, but inevitability. It is not one image. It is the convergence of many, pointing toward proliferation. Worlds in youth, in multiplicity, in maturity. Varied paths, shared visibility, the same potential repeated across the sky. History will remember this not merely as improved images, but as the moment planets became real to the eye, not just the mind. The moment we shifted from suspecting other worlds to beholding them. The universe no longer withholds its planets, it offers them. And now the opportunity falls to us. Because if planets are visible, if we can photograph their light, then the next images will not just be technical. They will be revelatory, connective, profoundly unifying. Stay on this voyage. Subscribe, turn on notifications, share with those who wonder, comment your thoughts below, and keep watching the skies. Because the barrier that separated us from other worlds is falling, image by image. And when the gallery fills, our understanding of solitude, of possibility, of our place among the stars will transform forever.